Today we're gonna learn about a serial peripheral interface. So we call it SPI. Actually, it's already in your Arduino. So what is the SPI interface? The SPI interface is a serial. We can call this is a serial communication that we can use to communicate with the other device. Okay, but the other device has to use the same interface. It's the same as the USB or the Ethernet or the Wi-Fi that you know. So for the serial peripheral interface, you need four pins. You need four pins. Okay, SCK is a clock pin. MISO is it means slave master. Sorry, slave master in slave out. Okay, and MOSI is means master out slave in. SS is mean chip selected. So what does it mean? SCK is mean clock. The same thing that we used last week. For the chip register, we have to use clock, right? To control the data, we need clock. And master in slave out is mean right now your Arduino is a master. Okay, master in slave out is mean you receive input from slave. That is slave right now. Slave is the device that you connect to. Okay, so this means for the pin MISMO you will get the data back to your Arduino. Okay, the pin number T, master out slave in, this means you send the data from the Arduino out to the device. Okay, send the data out from your Arduino to device. Okay, to peripheral device. And SS is means chip selected, because for the SPI we can use the same SCK, MISO and MOSI pin. Okay, we can use, if we have two devices, we can use the same SCK, MOSI, MISO pin. Okay, but we can use chip selected pin to select the device that you want to communicate to. You can use SS pin. You can create more SS pin. SS pin number 1 and SS pin number 2. If you want to communicate with first device, you can use SS pin number 1. If you want to communicate to device number 2, you can use SS pin number 2 to communicate to another device. So the pin SCK is 13, MISO is 12, and 11 is MOSI. And SF pin I define as a pin number 10. Okay, so for the SF pin, you can use another pin. Okay, for the SF pin, we can use another pin because SS pin is conventional general purpose input output. But SCK, MISO, MOSI, we cannot change. Okay, we cannot change. So if you see in this diagram, okay, if you see in this diagram, so I don't know, have already reserved the pin. Already reserved the pin for you. Okay, you can see D11 MOSI, D12 MISO, D13 SCK. Okay, it's already reserved the pin for you. This pre-pin, but for the SF pin, actually you can change to be pin number 9, pin number 8 is up to you. For the practice section, I will show you. Actually, we use the same pin that you used before last week. We use the same pin. So, from the diagram, pin 13 is the SCK, right? So we have to connect the SCK pin because we already know this is the clock pin, right? To the chip register clock pin. And pin 11 is the MOSI pin. So it means master out, this one is a master. Master out, send the data to slave. This is the slave. Okay, this is the slave. And the last one, pin number 10. Okay, pin number 10 is for the SPI format, we call the chip selected pin, right? So for the SF pin, we have to connect to the output register clock, that is the latch pin. Okay, that is latch pin. So I have to say you that the thing that I teach you is a standardized. Okay, for the SPI it is standardized, but I ask you to write the communication program by yourself, but actually it has the library, it has the concept. Okay, so you can search, actually you can search from anywhere about the SPI interface. Okay, it's a standardized serial federal interface. Okay, this is a standard serial communication that you have to know. Okay, that you have to know. Okay, because when you buy the new sensor, some sensor it has like a SPI interface that if you want to control, if you want to get the data for your Arduino, you have to know the protocol and the communication. So let's coding. Okay, you can check the circuit is the same. Okay, and we use the same thing. The clock. Firstly, we have to include the SPI.h. Okay, and we define pin. Actually, this is the same pin. Okay, and the same thing that you did, array to map between the 7 segment number to the digit. Okay, but I create only 3, 0, 1, 2. Okay, you have to compete by yourself, and this is a function that I write for you for the SPI, right? Okay, you just give them the data. Okay, this is the SPI 1 because we define SPI number 1 is a pin number 10 for the chip selected pin. Okay, so and we have the library ship out. Okay, ship out MSB first. MSB is mean the most significant bit. What does it mean? For the hexamal data on the left hand side is the most significant, right? If you forget, you have to know what is the bit that has the most value. That is the bit on the left hand side, it has the most value, right? Okay, so that means when we send the data, we have to define MSB first. That means most significant bit first. Okay, and then the same thing that we did last week, but right now this is a serial peripheral interface. We have to toggle the chip selected pin. Okay, so if we toggle chip selected pin number 1, it means this IC will be control, right? Okay, so actually we can copy to the second function and SPI2, and we can change a little bit if we want to control the two device, we can change we can copy and we just change the chip selected pin to pin number 2, and I will use the pin number 9 to be the device number 2, okay? But we can use the same MOSI, MISO, and data pin. That is the MOSI pin, okay? This practical, we just send the output from the master to the slave. That is the master out, slave in. Okay, so in the setup, we just define every pin as the output, and in the loop, we use the function like this. Okay, I will check to put the number 1. Okay, and let's start. Okay, this is the concept for the serial peripheral interface in the programming part of the Arduino, and I will show you how to do the 2 device. Okay, let's stop. Okay, right now I completed the circuit, so I will show you that. Okay, we use the same thing. We use the same pin 13. We use the same pin 11, but for the chip selected pin chip device number 1, we use the pin number 10. Okay, pin number 10. And device number 2, we use pin number 9. Okay, so we can right now we can control two device. Okay, with the SPI interface. Okay, so for the SPI is for the most benefit of the SPI is we can use this to control many devices at the same time. Okay, we can use only one Arduino to control many devices at the same time. That is the most benefits of the serial peripheral interface. Okay, you can see this is the SPI 1 and this is the SPI 2. Okay, I put different number. Okay, stop. Okay, I think right now you have already know about the SPI interface. Okay, let's practice. So for the practice section, you have to complete the SPI interface and show the number. Okay, but you have to show the number, but you have to complete the mapping of the 7 segment. Okay, 0 to 9. Okay, and then try to write the program. Okay, follow me, the same thing, but I need you to do something. Okay, I need you to do something. If I have the number, if I have the variable num equal to 10, okay, equal to 10, how to show oh sorry. Okay, if I have the number 10, how to show 1 and 0. Okay, let's think how to show 1 and 0. I put wrong resistor. Okay, 1 kilo ohm. Okay, if we have a number, the variable num equal to 10. Okay, this is a variable num equal to 10. How to show in 1 and 0. Okay, if I have a 11, how to show 1 and 1. Okay, how to show 1 and 1. So the assignment is if we give you 35, you have to show 3 on the 7 segment number 1 and 5 on the 7 segment number 2. Okay, this is your assignment for this week. Okay, let's try to think that is a benefit for you. Okay, let's try to think how to separate the number 3 and 5. You can use the programming knowledge to solve the problem. Anything. You can use the C programming first because you try in the Arduino. It's okay because it's the same language. Okay, this is a hint for you. Let's try.